Hi there. I would like to solve some polynomial questions that we have seen in the university entrance exams. The first question goes like this. P of x is a polynomial and x cubed plus ax minus 8 equals x minus 2 times p of x. Find p of 2. The problem looks like that when I plug in 2 for x, this will be 2 minus 2 is 0. 0 times p of 2 is 0, then p of 2 is going to be eliminated. So, but let me plug in 2 for x anyway. So x equals 2. 2 cubed plus 2 times a minus 8 equals 0. As 2 minus 2 is 0, 0 times p of 2 is 0. Then I can easily find the value of a here. So 2a equals 8 minus 8. So a equals 0. I found the value of a, which means x cubed minus 8 equals x minus 2 times p of x. I plugged in the value of a in the initial equation that was given here, so I can write this equation simply. We know that x cubed minus 8 can be factored as x minus 2 times x squared plus 2x plus 4. So I can write x for x cubed minus x this. So x minus 2 times x squared plus 2x plus 4 equals x minus 2 times p of x. So as you see, we can simplify x minus 2's, then p of x equals x squared plus 2x plus 4. What am I being asked? Let's remember, we have to find p of 2. P of 2 then easily found by plugging in 2 for x, 2 squared plus 2 times 2 plus 4, which is 4 plus 4 plus 4, which is 12. I would like to open parentheses for students who don't know how to factor x cubed minus 8. So I would like to remind you that a cubed minus b cubed can be factored as a minus b times a squared plus ab plus b squared. Therefore, x cubed minus 8 can be written as x cubed minus 2 cubed. So by looking at the above identity, it can be written as x minus 2 times the square of a, which means square of x, x squared, plus a times b, x times 2, 2x plus b squared. B is 2 in this case. 4. Another question was from 2002 university entrance exam, was as follows: x squared plus ax minus 5 equals x minus x plus 1 times bx plus c for every real number of x. This expression means that this is not an equation, this is an identity, which means it is true for every real number of x. So how can we solve this problem? Let's try distributing x plus 1 over bx plus c. As you know, what is x times bx? X times bx is bx squared plus x times c is c times x. 1 times bx is bx plus 1 times c is c. Let's simplify this expression. Bx squared plus c plus b times x plus c. So this expression must be equal to this exactly. The x squared here and the x squared here must have the same coefficient. So b equals 1. C plus b here must be equal to a, and c must be negative 5. So b equals 1, c equals negative 5. I can easily find a. A equals negative 5 plus 1, which is negative 4. So what is a plus b plus c? A equals negative 4 plus b equals 1 plus negative 5. Negative 4 plus negative 5 is negative 9, plus 1 is negative 8. In 2010, we see a slightly more difficult question about polynomials, which involves division of polynomials. So let's look at this problem. P of x equals 2x cubed minus m plus 1 x squared minus nx plus 3m minus 1 is divisible by x squared minus x. Then find m minus n. So what do we know about numbers? Like 12 is divisible by 6. What does it mean? 6 is 2 times 3. Then 12 must be divisible by 3 and 2. You notice probably that x squared minus x equals x times x minus 1. If a polynomial is divisible by x squared minus x, then it must be divisible by x, and it must be divisible by x minus 1. Let's remember the division. Dividend is divisor times quotient plus the remainder. We're going to apply this basic concept of division. As we stated earlier, p of x is divisible by x minus 1 and x, but I'll visit that later. X minus 1 times q of x plus the remainder, in this case it is 0. Let's try to identify these expressions. P of x, what is this? This is the original polynomial that is divided, which means it is the dividend. So what is x minus 1? X minus 1 is the divisor. Q of x is the quotient. I'm not really interested in finding what q of x is. And 0 is the remainder. So if I plug in 1 for x, p of 1 must be 0 because the remainder is 0. Why is it 0? Because I know that the polynomial is divisible by x minus 1. Therefore, let's remember what p of x was. P of x was 2x cubed minus m plus 1 x squared minus nx plus 3m minus 1. So p of 1 must be 0. P of 1 meaning that x must be equal to 1. Let's find p of 1. P of 1 equals 2 times 1 cubed 1 cubed here. 2 times 1 cubed is 1. 2 minus m plus 1 times 1 squared minus n plus 3m minus 1. So this expression must be equal to 0. Let's simplify this. 2 minus m minus 1 minus n plus 3m minus 1. Negative m minus m plus 3m is 2m minus n 1 negative 2, and this will cancel out. This is 0. We also know that p of x is divisible by x because it was given that it was divisible by x squared minus x. So x squared minus x is x times x minus 1. So the polynomial must be divisible by x minus 1, which we covered. Like secondly, it must be divisible by x. Okay, let's find that out. P of x equals x times, let's call t of x, because we used q of x in the previous division, so let me say the quotient is now t of x plus 0, because the remainder is 0. So what is p of 0? P of 0 is 0 times t of x is 0 is 0. So let's plug in 0 in the original polynomial. 2 times 0 cubed minus m plus 1 times 0 squared minus n times 0 plus 3m minus 1 must be 0. As you see, 0 squared is 0 and it will be eliminated, then 3m minus 1 is 0. Then m equals 1/3. Okay, what else did we find? Let's look. 2m minus n was 0 because we found that in the previous equation. So let's plug in 1/3 for m. 2/3 minus n equals 0. Then n equals 2/3. Let's remember what was being asked from us. It was m minus n. So let's let's find easily m minus n. 1/3 minus 2/3 equals -1/3. Another problem from 2012 university entrance exam is like this. P of x equals x plus a times x plus b, where a and b are elements of z plus. Z plus meaning positive integers. Another given is that the sum of the coefficients of p of x is 15. Then what is a plus b? Let's remember, how can you find the sum of the coefficients of a polynomial? Of course, by plugging in 1 for x. So p of 1 equals a plus 1 times b plus 1. Okay, let's remember x plus a. I plugged in 1 for x, then I plugged in 1 for x again. So 1 plus a times 1 plus b. So it must be equal to 15. Alright, so we have a very simple looking equation where a plus 1 times b plus 1 equals 15. We know that a and b are integers. Not only integers, they are positive integers. So a plus 1 times b plus 1 equals 15. Then let's try to find factors of 15. Like it can be a plus 1 can be 1, and b plus 1 can be 15, or a plus 1 can be 3, and b plus 1 can be 5, or a plus 1 can be 5, and b plus 1 can be 3, and a plus 1 can be 15, and b plus 1 can be 1. I have to eliminate the first and the last possibilities. Why? Because a plus 1, if a plus 1 equals 1, then a must be 0. But we know that a and b are positive integers, then these cases cannot be true. The last one is similarly not possible, because b plus 1 equals 1, then b is 0, which conflicts with the given of our question. So either a plus 1 equals 3 and b plus 1 equals 5, or a plus 1 equals 5 and b plus 1 equals 3. So if a plus 1 equals 3, then a equals 2, And if b plus 1 equals 5, b equals 4. In the second viable choice, we get the same answers, but the value of a and b are flipped. For example, if a plus 1 equals 5, a equals 4. Then if b plus 1 equals 3, then b equals 2. Let's remember we are being asked what is a plus b, so a plus b equals 6. So I repeat, a equals 2, then b equals 4, or a equals 4, then b equals 2. The sum of a plus b does not change. Another problem that university entrance exam guys would like to give you a hard time with is as follows. P of x equals x to the power of 11 minus 2 times x to the power of 10 plus x minus 2 is divisible. I'm sorry, it's not divisible. Let me delete that. Find the remainder when p of x is divided by x squared minus 5x plus 6. Let's first of all factor this polynomial. 6 is negative 3 times negative 2, which gives positive 6, and negative 3 plus negative 2 is negative 5, so it looks like I found the numbers. X minus 3 times x minus 2. We would like to find the remainder when this polynomial is divided by the second degree polynomial. And we can write it as p of x, which is the dividend, equals x minus 3 times x minus 2. This is the divisor, times q of x, which is the quotient, plus ax plus b. Why do I say ax plus b? Because when you divide a polynomial by a second degree polynomial, the degree of the remainder will be either 1 or 0. I can't be presumptuous that the remainder will be has a degree of 0. Then I have to assume that it is a first degree polynomial. If it is not the first degree polynomial, then a will be 0, then it will have the degree of 0. Let me rewrite the previous equation that I found out. P of x equals x minus 3 times x minus 2 times q of x plus ax plus b. So x equals 3. Well, let me give a value of 3 for x. P of 3 will be 3 minus 3 will be 0, and the whole expression will be 0 here. So 3 times a plus b. And p of 2 similarly is equal to, again, this expression will be completely gone because 2 minus 2 is 0, 0 times k of x is 0, equals 2a plus b. Let's rewrite the polynomial in the previous slide. P of x equals x to the power of 11 minus 2 times x to the power of 10 plus x minus 2. So P of 3 must be this. Let's find P of 3, which is 3 to the power of 11 minus 2 times 3 to the power of 10 plus 3 minus 2, which is, you will see a lot of these questions in the university entrance exam. In order to solve a polynomial problem, you need to have a very solid background in a lot of areas. For example, in exponents. So 3 to the power of 11 can be written as 3 times 3 to the power of 10 minus 2 times 3 to the power of 10 plus 1. So as you see, 3 to the power of 10, 3 to the power of 10, these are like terms. So 3 minus 2 is 1. 1 times, give me a second so I can delete this. 1 times 3 to the power of 10 plus 1. I want you to have a piece of paper and a pen and record this. P of 3 equals 3 to the power of 10 plus 1. So what is P of 2? P of 2 is 2 to the power of 11 minus 2 times 2 to the power of 10 plus 2 minus 2. 2 to the power of 11 minus 2 times 2 to the power of 10 is 2 to the power of 11 plus 2 minus 2. So they will all cancel out, and to our joy, P of 2 equals 0. Please write them down. I'm sure you put them down, that P of 3 equals equals 3a plus b, and also P of 3 was 3 to the power of 10 plus 1, and P of 2, which is 2a plus b, equals 0. So it looks like we have a simultaneous equation of two variables. So how can we solve this? You know this already. You can subtract the second, so take away, and this is already 0. B's cancel out. A equals 3 to the power of 10 plus 1 minus 0, which is 3 to the power of 10 plus 1. And what is b? Because 2a plus b equals 0, a equals 3 to the power of 10 plus 1, so b equals negative 2 times 3 to the power of 10 plus 1. So I can write the remainder. Remainder was ax plus b. Therefore, the remainder will be 3 to the power of 10 plus 1 times x minus 2 times 3 to the power of 10 plus 1. Another problem, and let this be the last one, so you have a lot of things to do on the weekend, so I don't want to give you a hard time, is p of x equals x squared minus 2x plus m, and q of x equals x squared plus 3x plus n. P of x and q of x have a common root, and px has double roots, then find m plus n. The last question looks complicated, but it is a very easy question. It has a lot to do with quadratics that we covered earlier. Px has double roots, meaning that, so let me ask you, what is the sum of the roots of p of x? The sum of the roots is negative b over a, it'll be 2. So if it has two equal roots, then they have to be 1 and 1. So from this we can easily find m, because we know the roots 1 and 1, so m must be, because the product of the roots is m over 1, so m must be 1 times 1, because let's remember, the product of the roots is c over a, m over 1, m. And we know the roots, 1 and 1, 1 times 1 is 1. So what is n? In this clue here, have a common root. P of x and q of x have a common root. P of x has double roots, which means 1 and 1. So if they have a common root, q of x must definitely have 1 as one of its roots. So what is the sum of the roots of q of x? Negative 3. So if one of the roots is 1, then the other must be negative 4. So n must be 1 times negative 4. Why? Because n is the product of the roots. So negative 4 times 1 is negative 4, n equals negative 4. What is m plus n then? It doesn't take a scientist to answer this question. M equals 1, n equals negative 4, m plus n equals negative 3.